No, I am trying. I don't either no hairstyle or hairstyle. I don't have any hair so to do some style.
Limited scope. Yeah. We're all getting there. I'm almost there.
Yeah. No, I actually due to COVID, I have made myself completely bald so that I don't have to go to the barber again. Yeah, for some time.
Right.
That's the easier thing to do. Yeah. So PhD students are there in your place, Adi?
Uh, well, for computer science, actually, I don't think many students are on campus. But yeah, IIT has allowed PhD students to come back. Mostly, I think it's in
Hmm.
other departments where they need lab access.
Hmm.
Yeah, so
Hmm.
that's where they're here. But in computer science, mostly I think everybody is working remotely.
Everyone is working from. Yeah, that makes sense. Mhm. Yeah, we are on live on YouTube, so whatever we say should be said fully.
Great.
Yeah. Just come.
So it's 4, and I see attendees are still joining. So should we start or give it a few more minutes? I'm pretty sure many more are in YouTube already watching.
Let's see.
Okay.
Okay.
So okay then. So let's start this session. So welcome everyone who joined us today and who are watching us live for the to the second session of today and last session of IndoML. This session is all about applications of AI and ML to the field of social sciences. And specifically, we have 3 fantastic speakers in this session to end IndoML on an excellent note. In these 3 talks, the speakers will touch upon cutting edge research on using artificial intelligence and machine learning to solve real world problems affecting both online and offline societies. Our first speaker today is in this session is Aiteshwar Seth. He is a faculty at the Department of Computer Science and Engineering at IIT Delhi and the co-founder and director of Gramvani, which is a social enterprise that uses technology to empower rural and low-income communities to run their own participatory media platforms. More recently, in 2019, Adi with his students have released a website to monitor biases in policymaking in India. And today he will talk about use of AI and ML to scale voice-based participatory media forums. So Adi, the stage is yours, and thank you.
Great. Thanks, Manak. Let me share my screen. Uh, yeah. So I hope you can see the screen and you can hear me properly.
Yes.
Great. Fantastic. Good afternoon, everybody. Cool. So before I begin, let me just take a minute or two to talk about this wide area of using technology for social development. So this area came up prominently about 2 to 3 decades back uh, under this broad heading called ICTD. ICT is for development, information and communication technologies for development. And the whole idea was that how can we use technology for social good, for solving problems like um, uh, awareness about health and nutrition practices in rural areas, or how do we use technology to improve that people can access government services more easily, or things like pointing out problems or questions that they have in agriculture, and they can get answers to some of these kinds of issues. So this has become a very vibrant and dynamic area over the years, and there's been many different innovations. And some of the work that we're doing at Gramvani is also a part of this large community of researchers and practitioners that has come together to use technology for social good. So one of the key messages that I wanted to bring out while I talk is that I'll talk a little bit about, of course, how Gramvani is also trying to use AI and ML to improve the scalability of our work. But more than that, I wanted to that as you go through the talk, I talk quite deeply about some of the operational work that goes into running such platforms, um, and which I hope will help you appreciate the hard work that is needed beyond technology. Right, so not just in terms of building technology that is useful, but to actually make that technology usable, to draw impact from the technology, requires a lot of non-technical work. So that I think is something that it will be great if students and everybody also appreciates about this effort of using ICTs for development. Because very often I get students who come to me and say, we want to do a project in AI, we want to do a project in ML, we want to do a project in networks. All right. So what typically gets them excited is the technical bits of these projects. So while all of those bits are very interesting, but I think it's good to also appreciate the wider lens of why all of these things are important and how they come together. Yeah. So with that, let me begin. And this is, of course, all joint work with a lot of people, at Gramvani, a lot of students at IIT Delhi who've also been collaborating on these projects. So the list is too long. I have a few names coming up here and there, but a few years back, I stopped putting names because there were just too many names of people who worked on these kinds of projects. Um, so let me begin with talking broadly about what is Gramvani doing. So now, so as you know, social media like Facebook, YouTube, while now we hear a lot of problems that are also arising with social media, but social media has been also quite beneficial in enabling people to talk about their problems. And this has been very important, because otherwise people don't have a media where they can raise issues that they face in their day-to-day life. Now, media, as you would understand, plays a very strong role in democracy. It's able to impose checks and balances. It's able to help people access information, become more aware. And these problems in media dark areas where people may not have internet, may not have television sets, and so on, it becomes very difficult. So there has been a lot of different mediums which have been used over the years to provide what we call participatory media or community media in such environments where internet or television and so on is not available. Right. So one of them is community radio. where you may have heard of these concepts where non-profits, they set up radio stations in rural areas. So on the bottom right, here is a picture of what a typical community radio station studio could look like, right? It's a very bare bones setup where people from the neighborhood, the neighboring villages, they come to the studio, they record programs, and these programs are broadcast on regular FM. Right, so FM is frequency modulation, so kind of what you use to access radio in your car, right? And here the content therefore becomes very local and participatory. Similarly, there have been fantastic organizations like video volunteers who do community video. So they train people from the rural communities, from local communities to create videos. And these videos, like over here, you see this large gathering of people where a video is being projected in the evening. And these videos are highlighting problems of corruption in these areas, or like school dropouts that where students drop out from school because of economic problems. And it helps make the community more aware. It helps draw attention of local stakeholders and policymakers also to these issues. Um, then there's a fantastic organization, Khabar Leheria, which has now gone digital. But until a few years back, they would do wall newspapers, and all these reports were in the local language and done by women journalists who would write these weekly newspapers and put them on panchayat walls so that people could access. And this is a photo from our own platform, Mobile Vani, where we use mobile phones. And I'll talk about all of this, right, for similar purposes. So the way all of this draws impact is that one, you know that communities are segmented, right, on gender, on caste, on power relationships. But if this community media station is able to draw representation, if it is open enough that anybody can come and talk about their issues, if it's able to give representation, then it can become very powerful because the information that gets produced is very local and is very contextual. That makes it more easily understandable by the people. So in agriculture, for example, if a farmer uh, uh, adopts a new practice and that farmer talks about it, then other fellow farmers will be able to understand it much more easily than, for example, if an agricultural scientist sitting in Delhi were to produce a program advising people on how to change their farming practices. Right? Plus, once farmers see somebody like them, somebody from their own community, adopting a practice and being able to run it successfully, that inspires them even more, right? It also gives a lot of empowerment to people because now they know that whatever they say, that can be heard by thousands of people in their village. And this brings a very strong feeling of empowerment, especially when you talk about marginalized groups and lower caste groups. Then it also becomes a strong medium for social accountability. So I mentioned this a couple of times that if you talk about corruption issues like you know about welfare schemes like Narega, you know about the ration card distribution system, and you know that there's lots of corruption that does happen. And a lot of this corruption also happens with knowledge of the local stakeholders, with some of the government officials. And yeah, the reality is that there's definitely coalitions, there's definitely nexus between many of these officials, which bring about the corruption also. But when these issues are talked about on a public forum, it brings them in the open and it puts pressure on the authorities to solve these problems. Right? Plus, of course, the medium also gives people the ability to talk about their own culture, their own folk songs. So, in fact, people in rural areas are very troubled by the Bollywoodization, right? And everybody wants to listen to Bollywood songs; they don't want to listen to their own folk songs. So while we can argue about good and bad, but the point is that these forums can be very useful in doing all this. So the way Mobile Vani works, which is the one of the projects that Gramani has been doing, uses IVR systems, interactive voice response. And this is typically what you get in a call center, where you call and you get this automated voice saying, press 1 for this, press 2 for this, press 3 for this. So what we have done is, we have built applications on top of IVR, where people give a missed call, our servers cut the call and call them back. And over this, users can listen to audio messages that have been published. But what brings it the power of participatory media is that users can also record their own message. Right now, what happens is that if somebody calls and they listen to message and they record their own message, then we have a content moderation team which listens to these messages and they figure out what to publish and what to reject. So they would take editorial policies into account. And now, for example, if somebody has called in to report a local news, right, like a citizen journalist calls in to report some local event that has happened, the moderation team reviews it and publishes it back on the platform so that other people can now also listen to it. Now, in the same way, it leads to a lot of discussion in the community because if this is a news about some local policy event, then many other people also report their own experiences about it, and it's pretty much like a Facebook discussion. Now people are able to engage in discussing these issues. So it's used in this way for question answering, where people call and record a question, other people can call and record answers. So lots of different use cases, which then get enabled, just like you would on social media. And finally, all the content that is being generated, we can also analyze it and we can connect it to different stakeholders. So like I was talking about corruption issues. So if such content comes in, then we can forward it to government officials. We can try to write reports about it. We work with the regional media to also carry these reports. So overall, it puts more pressure on the authorities to address these issues. So it can be very powerful, and we are running many such platforms for different purposes. So we're working with women's self-help groups where health and nutrition information is received by women, and they also ask questions of doubts that they have. This is largely on child and maternal nutrition. Then we have a very interesting platform which carries information on sexual rights and reproductive rights for adolescent boys and girls, where they call and they talk about doubts they have about sex, about relationships, how to deal with issues. So it's all very, very interesting, and it takes a very rights-based approach to addressing these questions. We're also working in the labor rights space, where these are factory workers, and in South India, we're working with women workers in the textile and spinning mills industry, where again, they call, they report problems they're facing in the factories, violations of working conditions, bad sanitation practices, or sexual harassment at the workplace. And these issues are taken up by the trade unions with whom we are running these platforms. Um, another interesting use case is with physically disabled people who use this in very interesting ways. And a lot of them are visually impaired, but they're able to use IVR systems easily. They use this to discuss, share job opportunities with each other. They advise each other on what's the best mobile phone model to use, and lots of such very interesting use cases. Um, Now, just to give you a sense of that, this is not just an online platform, right? Because now, one of the reasons why we started using IVR, I hope you would have gathered by now, is that because we're working in rural areas, we want to reach people who may not be very literate, who may not have smartphones. So that's why we boiled down to IVR as an inclusive platform. But even then, IVR alone is not inclusive enough, because on the ground there are still the communities are segmented, like I was saying earlier, with multiple caste and power based marginalizations. Women, for example, are not able to access phones very easily, because very often the phone belongs to the husband. There's one phone in the household, and the husband takes the phone with him. Similarly, even to tell people how IVR works can be challenging, because many people don't get this concept that they're talking to a machine on the other side. So we do a lot of offline work as well. So we actually train volunteers from the same communities, and these volunteers become our face. They run demonstrations of the systems in the community. They tell people how to use the system, and they inform them that such a system exists and how can they use it. So there's a lot of this offline work, which is essentially meant to ensure that even now that we have put a technology in place, we don't want that this technology should increase inequalities even further. Because otherwise, what we saw happening was that people who were skilled in using these systems, in adopting new technology, they were able to use IVR in very interesting ways. And to the extent that they started excluding other groups instead of trying to bring them on board. So we had to take these very careful decisions of who are the volunteers, how do we work with them, so that the whole representation aspect of community media could be realized effectively. Yeah. Then to give you an idea about the moderation, this is a picture from our moderation office in Ranchi, where the moderators, they sit and listen to all the audio reports that people are leaving, and then we run them through different editorial policies, which we've evolved over time, dealing with cyberbullying, politically motivated content. If people are making allegations of corruption against ration shop owners or against panchayat leaders, then we don't want to just publish them without verifying them. So we work with our volunteers for verification. We also make sure that the messages are recorded with a respectful tone. So we want to encourage debate, but we don't want it to be incivil. And that is one of the reasons why, because the content is moderated, so we've not had the kind of misinformation or hate speech kind of issues which have plagued social media platforms. Yeah. Now, another thing that we want to ensure through our moderation is that we want to give a complete coverage to issues. So, for example, what we've shown over here is that in Jharkhand, some years back, there was a strike of contract teachers. And they were demanding higher wages. And we try to ensure, however, that the messages came not just from para teachers, but from a range of different stakeholders. That our volunteers reached out to activists, to students, to parents, to also capture their feedback, and also to governments. And all of these stakeholders, as you can see, they talked about different aspects of the issue. And overall, we were able to therefore make sure that all the content that was being published on Mobile Money, that was very complete. And in fact, when we compared the same coverage of the same event in the regional media, we found that the regional media too wasn't as complete as what we had managed to make this event on Mobile Money, right? So essentially, a lot of the manual processes that go into running these systems become very important to make sure that the systems are being used effectively. They're not harming anybody, and we're not biased in any way, but we're able to give a complete coverage to all of these different issues. Yeah. So now the question is that so what we saw is that there's a lot of manual work involved, right? So how do we scale this up? And in fact, during the COVID lockdown, over even less than 2 months, from end of May to April, and end of March when the lockdown was imposed, to April and May when there was such a core crisis, we got over 2 million calls from all across the country wherever we were running these platforms. So of course, we don't have coverage throughout the country, but wherever we had these platforms running. So for example, in Delhi and Gurgaon, where we were working with factory workers, we had lots of issues of stranded migrant workers, which I'm sure all of you would be aware of how they were out of food, out of cash, and not able to travel, stuck with transport, confused about the options. Similarly, in rural areas of Bihar and Jharkhand and MP and UP, where we're also quite active, we had a lot of issues being recorded by people when they were running out of ration. The ration shops were not stocked up properly. They were out of cash. There were cash transfers that were announced by the government, but there was too much overcrowding in the banks. And many times these cash transfers also did not work. So we had a lot of these issues coming in, and we were desperately allocating them to our volunteers so that the volunteers could reach out to the people, they could help them, and also connect them with other partner organizations. So we were, by this time, we had brought in a lot of machine learning components, and we were able to deal with all of these issues. And that's what I want to talk about next. That now to scale up these systems, where all is there scope for interesting AI and machine learning opportunities? So now if you think about the pipeline, then what happens is that a new content gets recorded on the system. We then want to automatically identify whether the content is blank or noisy, right? So the audio is just not really publishable. And in that case, we want to reject it, and we want to prompt the user in real time to try and do a recording again, right? Once a good quality recording comes in, we want to get the speech to text output. And here we don't have our own system. We use commercial speech to text systems like from Google and Amazon. So we fetch the transcript, and then after that we do a topic and aspect classification on that. So topic classification meaning that we broadly try to identify whether the audio message is something to do with health or something to do with agriculture, so that we can treat it appropriately. If So, for example, some of our volunteers are working on agriculture, some of them are working more on government schemes and grievances. So, we can allocate it appropriately based on the location and the topic of the audio, right? And then what we want is that if it's a news or opinion, we want to publish it on the platform, but we also want to publish it so that it takes care of some of the completeness principles that I talked about, right? That it brings in some kind of a fairness, so that not just one aspect of an issue gets covered a lot on the platform, but some aspect which may not be reported very much is also given adequate exposure. So, taking the example of the teacher strike, we want to make sure that not only the teachers' demands are being raised, but also problems raised by parents are also published on the platform. So, we want some automated ranking so that there can be some fairness and diversity guarantees that can be provided. Then another use case is that if it's a question, then so far we are doing this question answering manually. That somebody calls and records the question. Our moderators listen to this question and they send this question to an expert. The expert records an answer, and then it goes back. The answer goes back to the person, right? But now over time we have built up a knowledge base of these questions and answers. So we also want to see that can we pull out an answer automatically. So this is an area called fact retrieval, frequently answered questions retrieval, right? That you have a database and now a new question comes in. In real time, you do a speech to text of the question and you're able to pull out an answer and play the answer back to the person. So of course, if the person is not satisfied with the answer, then they can indicate that and then we can send the question to an expert as the usual process. But if we can do it right there and then, if we can answer the question, then that's great. It gives immediate actionable information to the person, right? Similarly, if it's a grievance, so like I was saying that if we can identify the type of grievance and the location from where the grievance has been recorded, then we can route the audio appropriately. So I'll talk a little bit about some of our successes and where there's scope for doing this in the first part. So here, for example, if the audio is blank, so now fortunately, while over the years we've been running Mobile Vani, we, uh, uh, we have been able to collect a lot of ground truth data essentially. Because the moderators, when they would reject the content, they would mark it with the reason for rejection. And if they would accept it, so now all that database which has been accumulated over the years was very useful. So we were very quickly able to build a classifier to identify whether the audio is blank or not. And it's a very, very simple, straightforward thing. A simple random forest classifier, which just looks at standard audio features and is able to do a great job. But when it came to also detecting whether the audio is noisy or not, we're not able to do as well. We get about 89 to 90% accuracy. And the reason is that the annotation of noisy audio doesn't differentiate between different types of noise. So now some of the noise is due to external environment issues like horns or birds tweeting in the background, which probably a classifier that uses frequency-based features, spectral features, will be able to detect. But a lot of the noisy audio, which is marked as noisy, is also because of you were in a noisy room where there are multiple people speaking at the same time. Now, the frequency-based features are not able to distinguish between these. So we're trying to use a CNN-based approach now, and we'll see how that goes. But the point is that had we anticipated some of these issues earlier, maybe we would have done a much nicer, more fine-grained annotation of the data, so that we could have built a noisy classifier for high frequency, for frequency-based noise, and another one probably for detecting whether there's a single speaker or multiple speakers speaking at the same time, and which then reduces the quality of the audio. Then we try to understand that the audio which is of good quality, if we send it to a speech to text, is the speech to text good enough? So here, for example, what we did was we took a bunch of audios and we manually transcribed them, and then we compared these manual transcriptions with what Google and Amazon were giving. So roughly we saw that about 80% of the audio had less than a 30% word error rate, which is probably not good enough for a word-to-word transcription. But what we were interested in was that can we use it just for a broad topic classification, right? That maybe we can still capture even this 30% word error rate might still be able to get some of the main keywords which might be useful for topic classification. So far we're doing about a 70% accuracy on that. Um, Similarly, we wanted to see if we can identify numbers in this audio, and we're getting about a 65% accuracy. So lots of scope for improvement of speech-to-text systems to make them more comfortable to the rural dialects which are being used. So the commercial systems are still not as good. And here are some examples of from the project that we were doing on sexual and reproductive health of how some of the words are incorrectly recognized. And so one of the things that we've also done, and we'll be very eager to look for collaborations, is that we collaborated with Mozilla, and Mozilla helped us transcribe about 130 hours of Hindi audio that has been captured via our systems. So this is very interesting because the audio which is being captured by our systems is from it is carrying the local dialects which are spoken in parts of Bihar, in parts of Jharkhand, in parts of Madhya Pradesh. And this is a very rare data set, which typically you would not get otherwise. Um, and Mozilla then helped us transcribe all of this word to word, and this is now available free of cost for academic use. So we have collaborated with some researchers who are doing speech to text, and we're more open for other things. As I understand, this 130 hours of audio is non-trivial, and if we can use this to improve speech to text, then some of the problems that we are seeing over here will hopefully go away, and we'll be able to do a better job. Yeah. So next, let's see. There's very interesting problems that we can do in this fairness-based ranking of content. So to give you a cleaner example of what I mean, so again, going back to the teachers' strike example, right? So we saw that there are different aspects of the strike which are important. The teachers are saying something, but the parents are also saying something else, and so on. Now, if you just go by the number of content that different stakeholders have reported, it's possible that teachers may have been the most vocal on the platform. And therefore, if we were just playing the content as and when it is recorded, then we would give a lot of coverage to teacher issues and not to other issues by parents or by government officials, right? So if, however, we're able to identify these different aspects and we're able to impose some fairness guarantees, then we can do much better. We can make sure that even though few content may have been recorded of a perspective, but we give it more exposure, right? Over here, we churn the content more actively among the teachers, but the red content and the green content, we give it more exposure so that more people are able to get exposed to different views of the issue. Right? And then what we wanted to do is that can we build algorithms which can do a short-term diversity with a long-term fairness, so that it doesn't happen that when a person calls, they just listen to a lot of items, but from just a few aspects. So what we want is that if there's short-term diversity also, then we can expose the user will get to hear multiple viewpoints on any time the user calls. And so we wanted to see that can we build policies so that platform managers can have access to these different configurations that they can make on the system. So I won't go into the details, but we tried different things, and this is a Gini curve, a Lorentz curve. So y equal to x times means perfect equality, that all the aspects get equal attention. And what we actually saw was that manual moderation was quite far away from the y equal to x line. So manually, the moderators were not able to give a great coverage to all the different aspects. But then as we applied some of our algorithms, it was able to do much better. So now we want to implement these algorithms in our technology stack so that a lot of this content ranking can be automated and we can give more complete coverage to different issues on the platform. So similarly, we also look at short-term diversity. Yeah. So then I'll next talk about some other work we're doing on question answering, where we essentially want to pull out an answer from an FAQ database. So like I said, so far we've been running a bunch of these programs, and we've effectively collected a data set which has been built up manually, where for every answer, we have a bunch of questions. So these are essentially different ways of asking a question that in which people ask something for which the same answer is okay. These are a bunch of other questions that they ask, which are all similar to one another, for which another answer is satisfactory. So like I said, we want to build a system so that now when a user just records a question, we're able to uh, return the answer. The way we're actually trying to do it is that instead of pulling out the answer, we want to pull out other matching questions and give three examples. Did you mean this, or did you mean this, or did you mean to ask this? And once the user is able to select, and you play the answer, and so on. So we try to see what can we do with existing speech-to-text systems. Um, so here we tested with simple models. So we used Descartes similarity, and then we used a deep learning a transformer model called BERT. And initially we tried just using automatically transcribed data, and we got a very low success rate. Success rate in the top three results, that is anything in the top three matching the correct answer, and we got a very poor result. But we were able to improve it further because we said that, well, training data we can transcribe it manually, right? Because this is offline, so we can do it manually, and that uh, improve the situation. Then we went further. We said that, well, what if we consider only the relevant portion of content? So here is an example of a question where the user also gives a lot of superfluous information, which is not really relevant. So he says that I'm speaking from Madhubani in Bihar. It has been almost 5 years since we got married, but as of now, I've not been able to have a child. So what should my wife do? So the relevant portion is actually only so much, right? The rest of it is not relevant or may be relevant for some context information. So again, if we are able to, in the training data, we mark the relevant portion so that we could build a much sharper classifier that is able to just pay attention to the relevant portion. So that helped. And then we did further that, well, what if we take an input from the user in advance, right? Just one more data point that do you want to ask something about family planning, or do you want to ask something about the love relationship, or do you want to ask something about, let's say, third topic? So if we're able to get an input from the user about the theme, then a search space reduces because now we just have to search in a much narrower space. So that also helps. And if we're able to combine data from different sources, because all of these are from the same areas, if we're able to combine data from the mother and child question answers to also the sexual and reproductive rights question answers, and also the worker database, then also it improves. So now we're actually getting a reasonable accuracy, which again is not that good, but still it gives us confidence that we can probably now go for a production level system. So we've put some of these systems in place, and we're in the process of collecting more information from the users to get their feedback about the product, and there's many other things we're also discovering in the process. Yeah. So the next thing I'll talk about is on grievances. That once we do get these grievances, we want to allocate. Now this also becomes very important because so here, so I won't have time to explain in detail, but there are many different reasons for exclusion from welfare schemes. Sometimes people are not able to enroll because the government officials or other people at the local level, they don't cooperate. Sometimes there can be problems that the electronic systems can reject your registration because of spelling errors. Sometimes there can be problems because your Aadhaar is linked with somebody else's bank account, and therefore you're not getting the credit. And finally, when you do go to withdraw, there's also many cases of agent fraud where somebody may take your biometrics and the authentication might go through, but you're told that the authentication failed and the agent is able to pocket the money. So we get a lot of such grievances, and what we want is that if we can automatically categorize all these grievances, then we can potentially even build websites where we might be able to show some of these grievances. So this is, for example, a consumer complaints database in the US, and we might be able to build something similar where we're able to show that what are the big issues on which people are facing problems. So this becomes very important from a transparency point of view and for policy advocacy, because then we can actually go to policymakers and say that, well, so many people have recorded these complaints on our platform, and these are the main reasons why people are facing exclusion from government schemes, and you should definitely do something about it. So that's a broad goal, that we want to collect these grievances, and we of course want to help people, but we also want to show it on this kind of a public interface. So now to collect these grievances, we're now building a voice bot, so that we can guide the person to collect as much specific information, that what government scheme are they talking about, what is their grievance, and then other related things, like if it's about ration, then we also want to know how many family members are there, or how long has it been up, uh, 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 since you logged the problem, since you raised it to some government department, but there has been no action. So all of it can help us bring in valuable data which we can use for policy advocacy. So now similarly over here, we're working on the speech to text output, from where we're trying to see if we can extract location from the data, if we can extract some entities, number entities like age or number of family members or attendance. Can we get the date of birth? So there's accuracies that we're able to get at different levels. We're able to do better than Google's dialog flow, and we're trying to improve it further. But yeah, again, there's lots of scope for trying to do this in a much better way. Yeah. So since I'm running out of time, I'll probably skip one of these sections. But I'll come to another aspect of scaling. So while we've been talking about how do we scale the backend, another very important aspect is gets conveyed from this graph. So what this graph shows is what is the cost of user acquisition for us. Cost of user acquisition means that we have volunteers who go to the field, who tell people about the platform, and that brings in new users onto the platform. But we see that there's a wide range, and a lot of the platforms where it is very easy for us to acquire users, these platforms are typically which are used by youth. So these could be related to career counseling, these could be related to jobs. But when it comes to some of the most expensive platforms, it is about women. And that is fundamentally because you might see pictures like this. This is actually a picture from our own project, but there is a big question mark over here, that how easy is it for women to use mobile phones? How easy is it for us to even reach women in the first place, to tell them that such a system exists? And this has essentially to do with existing inequities in our social structure, right? Because of patriarchy, because of gender norms, it is not easy to reach women so easily. So we've had to we work with women self-help groups, which provides us a strong platform to reach women, um, to do that. But here there's another very interesting case that we're working on. That what if we can collect phone numbers to whom we can then send messages, and along with that, can we also collect information if there is any family member who is pregnant, or are there any children below 6 months, or any children below 2 years? Because if we do, if we're able to then capture these phone numbers, then we can automatically send messages also to these beneficiaries of useful information. And that can be one way to reduce the digital gender divide. So that because it's harder to reach women, so if we can get their phone numbers, then how well does it work? So here we're using optical character recognition, where because not everybody, the field workers on the ground, they're not savvy enough to use mobile phones or smartphones to enter information, and therefore we say that, well, you can fill information on paper forms and then just take a photograph of the form, or rather don't even take a photograph, just send over the forms to the head office, and we will scan those forms, and from that we will through OCR we will automatically extract this. So we're working on this. We're getting better and better. Now we have a digital level accuracy of almost 94%, and there's several different things that we've done by augmenting it, by adding different types of noise, hard negative mining, and we're also trying to disambiguate using handwriting. because these forms are filled by the same health worker or the same SHG coordinator, where we have these kind of cases where uh, uh, this kind of a digit, it may not be very obvious whether it's a 2 or a 9, but if you compare it with other ways in which this digit has been written in the form, then you know that well 9 is written as 9 and therefore this is most likely a 2. So we're working on such computer vision problems with other colleagues at IIT to try and also use this. So in the same way, we're also trying to see if we can get information from vaccination cards by taking a photo of the vaccination card. So here these vaccines are the vaccination card records where the health workers maintain information that which vaccine was given when to a particular child. Now this card is not digitized, the card stays with the family, but they bring the card with them, then they come for vaccination. So if a photograph of this card can be taken and along with it, we're able to get the phone number of the person for which we have a mobile application that collects that. Then we can also send them reminders of next vaccinations. We can also send them surveys to check whether they actually got the vaccination or not. Because in vaccination, there are also cases of pilferage that happens where vaccines are reported as given, but actually they have not been given to the person and they're sold in the black market. So we're using attention RNN based models for some of this. And all this is work with a large number of partners whom we should acknowledge. Yeah, but I'll stop. And the main point that I wanted to leave you with is that there's many exciting opportunities, right? But uh, uh, we should not get just excited by solving a cool technical problem. Rather, there's a lot of hard work to understand the context, to understand what is the right place to fit a solution. And this is where applications and partners are very important. And there's also a very strong way to think about using AI and ML that we should always, I feel we should always think about removing the inequalities that are created by technology and not to, and that's the opportunity to use technology and so that, and not to introduce more and more technology among people who already have access to good technology because that will only worsen the inequalities even further. Yeah. So I stop now, and I'm sorry I've taken much longer than what I thought.
No, it's so it's. I think it was a fantastic talk, and yeah, I think we all enjoyed it. So just quickly, and I think we're right on time. So can we
Okay.
just take like 2 or 3 minutes as there are two questions,
Sure,
so we
sure.
can possibly just quickly discuss about it before we move on to the next one. So the first question was that the data that you worked on, like the regional or rural data, that is extremely difficult. People understand that, and both from the perspective of quality and quantity. So how are you solving it, or do you want to solve it or improve it?
Yeah, so like the speech to text data, for example, we have a lot more data also, which is audio data, and because it's recorded via an IVR system, that brings in its own challenges also, right? Because on IVR the bitrate is only 8 kilohertz, so the quality is poor. But if we can make it work on IVR, then it means that that's like the lowest common denominator. Even now, I mean, there's a lot of hype that smartphones and everything are going to reach everybody, but I mean, it's still far out. I can at length talk offline about these reasons. Um, but yeah, so the data is there, and we're looking for collaborators. Anybody who wants to work on like speech to text systems to improve all of this, then that would be fantastic.
Okay. The second question is from S. Durga Bhavani on whether you are using some formal methods or techniques from social science research. Like, do you have social science researchers in your team? So,
Um, yeah, so in fact, I skipped pretty much this whole section, but this is one place where we also want to use this data. That now, if you think about it, we have all of this data coming in where people are talking about problems they're facing or talking about local news from their area. Some of it is about floods, some of it is about droughts, some of it is about crop failures. And that becomes very useful to publishers. Use it to explain um, uh, many reasons behind different pace of development. So, for example, what we've been doing is, as part of other projects, is using satellite data. We're trying to see if we can use satellite data to find out different phases of development. So here, for example, according to the census, these were some the red ones are low developed and so on districts. But now the question is that uh, why did some districts go from red to green, but some other districts they just stayed in red, right? What is it that makes them distinct? And in the same way, in cities, so this is a map of Delhi, and these different color codings represent different areas where some are very crowded with very poor living conditions. These are mostly slum areas, and others are much nicer developed residential localities, more posh areas. So, what is the lived experiences of people? So here again, voice data can be very useful. So one of the things we're doing, and I'll skip the details, of course, but we're trying to, so far, because we don't have voice data from all the districts as such, we're using mass media data. And we're trying to see if we can use mass media to this data to explain different patterns. That what is it that makes fast-growing agricultural districts different from agricultural districts which developed much slowly, or fast-growing industrial districts from industrial districts which did not grow very quickly. And by growth, I mean changes in socio-economic development as observed through satellite data in terms of road construction, in terms of uh, faster urban development, and so on. So this can help us also understand some of these aspects.
Okay. Thanks a lot, Adi, for the talk and for taking the questions and the interaction. So I request the other attendees to actually move the discussion to offline. If you have more questions, I'm pretty sure Adi will be happy to answer some of your questions. So the next talk in this series is by Professor Sudhindra Hangal, who joined us. Sudhindra is a professor of practice at Ashoka University, where he also co-directs the Trivedi Center for Political Data. His research spans political science, neuroscience, library information science, journalism, and e-governance. And his work draws upon techniques from human-computer interaction, text mining, program analysis, and computer architecture. Suhendra is also the CEO and a co-founder of Amuse Labs. And today he will talk about something which directly or indirectly affect majority of us, which is the challenging problems in Indian political data. So, Suhendra, the stage is yours. And without further ado, looking forward to your talk. You are muted, Suhendra.
Hello, can you hear me now?
Yes.
Okay, great. Just give me a second to set up my windows and sharing. Okay, can you see my slides now?
Yes, it works. Thanks.
Okay, thank you, Mainak. Good afternoon, everyone, and thanks to the organizers for inviting me to talk about problems in political data. I'm speaking here on behalf of the entire team at the Trivedi Center for Political Data at Ashoka University. And what I'm going to be talking about is the work of many staff, students, interns, researchers, affiliates, etc., over the last 4 to 5 years. So for those of you who don't know about Ashoka, we are a private philanthropic university, relatively new. We started in 2014. We are just outside Delhi in NCR. We have UG, masters, and PhD programs in a wide variety of disciplines. We started with primarily the liberal arts subjects as well as computer science, and now we also have basic sciences. The university has about 2,300 students, about 190 faculty, and we plan to double in the next few years. We got a new piece of land, so we're about roughly doubling in the next 3 to 5 years. So we're hiring for both faculty positions and for PhD students. So do apply if you're interested. To tell you a little bit about the Trivedi Center for Political Data. So we have many research centers at Ashoka, of which one of them is the Trivedi Center. It is co-directed by myself and Professor Gilles Vernier from Political Science. So the goal of the center is to promote data-driven discourse on India's politics. So what we primarily do is acquire, maintain, and disseminate in various forms reliable and clean data sets related to Indian politics. And I'm going to give you a few examples in a while. We also build tools specifically for dealing with problems with Indian data. We also conduct some research on the data ourselves. Although all our data is open source, we provide it freely for anyone. It's on GitHub. All our tools are open source. And of course, we have a completely non-partisan agenda. And we, of course, train students, researchers, both in computer science, in political science, and other disciplines in data-based analysis, particularly with the data sets that we work with. And finally, we try and advocate for open data policies within India. So for those of you who may not be familiar, there is this open data maturity model. Some of you may have heard of. This is proposed by Tim Berners-Lee. So this is on the lines of the capability maturity model for software development. So the idea here is that is to rate different agencies, particularly governments, with respect to how open they are with their data. And what the model is, awards 1 to 5 stars, depending on how open a particular organization or government is with data. So you can see at the very bottom, the first star is, if you just put your data out in some digital format, that means the data is available on a website, doesn't matter in what form, at least someone can download it and look at it. You don't have to, file a RTI or a Freedom of Information request just to get the data. So you have the data in some form, although it may not be computable with. The second star is if the data is in some computable form, like Excel or some spreadsheet or some machine readable form. The third star is if it's an open machine readable format, something like a CSV file that doesn't require proprietary tools to tackle that data set. The fourth star is if your data is in RDF format, so it has a somewhat extensible schema. And the fifth star, which of course is kind of a holy grail, is linked open data, where you can, you have standardized schemas and you can connect data sets across, different data sources, different domains, and so on. Okay, so that's of course very utopian. In India, I think we are mostly lucky to just have data as PDFs. You may have heard of initiatives like data.gov.in, which are announced with much fanfare, but when you actually go and look at what is there, it's often not very relevant, or it's very coarse-grained, or it's out of date, etc. So it's very hard to use, to really make use of it. And one of the things we try and do is educate government departments about this model and encourage them or help them if possible to disseminate data, at a 3-star or more level. There are some arms of the government that do release data in better formats. For example, the census data is relatively clean, relatively machine readable, but it's not connected to anything else. Or if you look at other survey data, like the National Family Health Survey that just came out this week, again, that data is not available as even as CSV files. It's there as PDFs, and you have abstracted data, but you can't get to the granular rows that are behind that data set. So it's hard to perform computation with them or do deeper analysis, right? So in the Trivedi Center, we have kind of worked on 2 or 3 different data sets in some depth, and I'll describe some of those in the next few slides. I should say that rather than present clever solutions, I'm going to basically throw out interesting problems, which I hope makes for a more interesting talk. Most of the work we've done is fairly straight algorithmic work so far, but we see a big application for good AI and ML techniques in the future. So we welcome collaboration from anyone in the audience who might want to work with these data sets. So let me jump into it and give you a flavor of some of the data sets that political scientists are interested in or are of high value to them. So the first and most obvious data set is just electoral data. So India is the largest democracy in the world, over 900 million electors with a pretty high turnout ratio. I think it's fair to say that the Election Commission of India is a model for conducting elections across the world. It's the envy of many countries. And it conducts elections at 3 levels, but we are going to primarily consider the top 2 levels, which is the parliamentary elections for the lower house of parliament, which consists of 543 seats. And then in every state, there are assembly constituencies, of which there are a total of about 4,000 and some across all the states. And elections are conducted every 5 years, both for the parliament and and in each state. There's approximately one election every 6 months or so. And if you look at the history of all of these elections in independent India from 1947 onwards, the data set is actually not that large. I'm talking about everyone who has contested an election in India and where they contested, how many votes they won, which party they represented, etc. So all the variables associated with a particular candidate contesting an election. So if you consider all these candidates, it's not more than 1 million rows. So from a computer science perspective, it's actually not that big a data set, but it's a very high value data set. It's something that political scientists all across the world study in a great amount of detail. Many books and many PhD theses are written on every single election that is conducted in India, etc. Right. So this is a very high value data set and something that's subject to a lot of scrutiny. So it's important to have good and reliable data on which people can perform that analysis. However, what we found was that for the most part, there was no one good source of elections data in India. There were individual researchers trying to cobble together data sets useful for a particular problem that they were interested in, but then that data is thrown away after that analysis. There is no long-term maintenance of that data or no refresh of that data when some new election is held or new information comes out. One of the main goals of the center has been, and this is something we've spent a lot of effort on, maybe about 15 to 20% years in the last 3-4 years, is just to put together clean, usable, and open source electoral data since 1962 for all Indian elections at the parliamentary or the state level. We also try to take this data and integrate it with multiple sources of information so that we have a very rich data set. Like I said, we may have less than 1 million rows, but we have, maybe up to 100 columns on every row. So we have fairly granular information where possible on every candidate who has contested the election. And what this does is it provides a resource for researchers, for journalists, for students to, ask and answer interesting questions about who's contesting Indian elections, what are the trends, what are the outcomes, and so on. Okay, so to give you an example of election data, this is the kind of map that all of you are probably used to seeing after every election. This is a map of, it's a map of which party won which constituency. This is the 2019 general elections. And it's color coded by party, etc. So this kind of thing is easy to generate. But if I ask you something like, what's the long-term trend of women's participation in Indian elections? Now that is not so easy to generate. So one of the goals of our data set is that we have clean and vetted data over time, at least from 1962 onwards, right up to the last election, which was in Bihar last month. And you can answer questions like this: what is the gender-wise voter turnout in the national elections? And as you can probably see, in 1962, it was slightly more than 60% for males and slightly less than 50% for females. That has gotten equalized to a large degree in the 2019 elections. Right? So that's an encouraging sign. So our data set allows or enables this kind of longitudinal analysis on a bunch of variables. So let me now come to some of the technical problems that we have to deal with in order to build this kind of a data set. So first of all, just very basically, there are data ingestion problems. So the source data is typically in PDF files, and this is a problem that's familiar to many of you, I'm sure, who have done data scraping or tried to deal with government data. In our case, it's exacerbated a bit because we are dealing with longitudinal data. So we're dealing with data which comes from PDF files that were created from files that were scanned, from a 1962 paper report somewhere, right? So the data is very, so the original source of the data is in these things called statistical reports, and the statistical reports are published by the Election Commission after every election, and it has a large number of sections. Many of these sections are kind of overlapping or redundant, so it's not a normalized schema in CS terms, and it's sometimes inconsistent, etc. So the first challenge is just getting digital versions of these files, and then further over time, what you'll see is that the formats of these files are very different. So this is the 1980 file, and this is the 2019 file, and you'll see the formats in which essentially the same data is put out is very different. That's natural, right? Because over time there is format drift, and it's very hard to keep a consistent schema, let alone a format, over time. So we have to kind of parse. There are, I think, more than 300 such files that we have to parse, consisting of maybe at least 20, 25 different formats. So we have to come up with a kind of processing pipeline to handle this data and clean it up and emit it in a kind of normalized schema. So this is an overview of the data parsing pipeline that we built. So we take the original PDF, if needed, we OCR it and we generate text from it. But then the text is kind of it follows many different templates, right? So one of the things we did was built a little domain-specific language that that built a state machine-based parser that would go over these different formats and try and figure out um, where different fields were. So there were fields like, this is the candidate name, that's the party name, how many votes they won, how many votes were polled in the constituency as a whole, how many votes were postal ballots, and so on. And one of the things we realized was very useful in trying to build this parser engine was to write invariants on the output data that was expected. For example, if you're expecting data in a particular column which has a certain data type, like it has to be a number, it has to be a positive number, or it has to be from an enumerated space of possibilities, like gender has to be male, female, or other. So these kind of things, we wrote data consistency checkers for it. Whenever something like this failed, we realized we need a new rule or a transition in the parser, and then fed that back. And using that, we were able to kind of get relatively clean data out of these 300 some statistical reports. Of course, we also find that there are errors in the source data. I mean, the source data is never completely clean, so it ends up that we find things that don't make sense. We find vote counts that don't make sense. We find vote counts that don't tally with what is supposed to be the total number of votes in that constituency, etc. And in these cases, we try and feed this information back to the election commission so they can look it up if they have original source records somewhere else, or just for their further analysis or information. So once we have this data set, and like any kind of data manipulation project, I mean, 80% of your time goes in just data cleaning and organization, right? So that's what we found in this case as well. Further, we take what data we get from the election commission, and then there are other sources of interesting information about electoral data. So even before that, there are inherent complexities in the electoral process itself. For example, constituencies and states constituencies get changed with every delimitation, and even states have been reorganized or broken up in the last few years, or the state codes change and so on. And so just reconciling this over time and having it in a way that makes it possible to ask sensible questions over time is a challenge. It's pretty hard to get spatial data, like what are the constituency boundaries even. We have such data for the current delimitation, but we don't have this data going back, and there's no one in the government who's willing to give it to us. It's not clear that they have the data in digital form either. And then there are all these complications of fragmented elections, by-elections. So just coming up with a consistent schema for representing this is quite an interesting problem. Secondly, the data set is made more useful if you can combine it with other sources of information, like candidates' affidavit. So since 2004, every candidate who contests an election has to file an affidavit, a sworn affidavit, with their financial records, family information, criminal cases against them, etc. So this information has been mostly digitized by the Association for Democratic Reform, but there is no connection between that data and what the Election Commission puts out, right? So we can't really ask questions like, are people with criminal records more or less successful, and so on. Similarly, the Lok Sabha puts out information about people who actually make it to the House, the winners of these elections. Or PRS Legislative Research puts out data on all the bills and debates in Parliament. But again, that none of these are connected to each other. So part of our job is also trying to um, map the records that we have in the elections data set with information from other sources. One interesting problem that comes in the elections data set, it's kind of surprising, but there is no identifier, there's no single identifier for a person who contests Indian elections today. Candidates are not required to provide a PAN card, Aadhaar, or any such thing. And in any case, those things are fairly recent. So political scientists are unable to ask very fundamental questions that they would like to, like, what is the rate of new people entering the political system? Is it the same people trying again and again? Or are there new aspirants to office, which would be a sign of a healthy democracy? Um, how does prior experience affect electoral outcomes? So in India, we have all these theories of, pro incumbency or anti incumbency, but it's very hard to have. There's no data to back. You don't even know who's an incumbent and who's not. So it's hard to answer questions analytically. Um, which parties are more welcoming of newcomers? How successful are loyalists to a party versus people who switch parties? So these kind of questions were very hard to answer earlier, which is why we embarked on a project to assign an identifier to everyone who contests an Indian election at the state or the national level. And that project, we've been working on it for about a couple of years, and we've got it, I'd say, mostly done. It's not 100% perfect, but I'd say it's more than 90% there. And we had to build certain tools, which I'll describe, to handle the problems in mapping people across time and across elections. So in particular, there's a wide variation in the way personal names, as well as even constituency names and party names, are spelled across time. So as anyone who's probably dealt with Indian data knows, there's a wide variety of ways in which people spell your name. Um, Here's an example of a prominent politician like Krishna Advani, and this is real data from, say, 1989, 1991, 98, and 99, and 2004, where his name is spelled in 5 different ways and completely different formats. It's Lal Krishna, Lal Krishan, first name, last name, or last name, first name. There's an alias in brackets, there's initials, etc. And this is for a prominent politician contesting mostly from urban areas, right? So same thing happens for parties. Same thing happens for constituency names, etc. So one of the challenges is just knowing who's the same person in this data set across time. And so we've embarked on this project, like I said, and we built a tool called SURF, which does entity mapping and resolution for Indian names across time. So it's a human in the loop entity mapping system. It's not completely automatic, but what it does is clusters similar names together, and similar names are not just similar names based on edit distance or something, but there's a range of algorithms that map people who could possibly be the same together, and try and assign them an ID. And this is not possible, with existing data cleaning or entity resolution tools. So just to give you an example, I mean, even simple tokenization is a challenge. So people will spell, Prem Kumar versus Prem space Kumar, or they'll have aliases right in the middle of the name, and so on. So these kind of very unique Indian problems. Initialization, like I talked about. So Surf, the tool that we built, has a bunch of clustering algorithms, which of course use simple things like edit distance and soundex, but then bolts on some of these very specific patterns that we see for approximate name matching, and has other smarts about temporal data. For example, if you have a politician like Atal Bihari Vajpayee, who contests, let's say, 11 elections in a row, but you can find his name only, maybe in 5 elections and then 5 other elections, and there's a gap in the middle. So now that's a pretty good sign that it's unlikely that he would simply not have contested in the middle. So, SURF would do sort of more relaxed entity name matching to try and find Atal Bihari Vajpayee in the election that was missing in the middle. So look for streaks of that sort. And then there's a whole bunch of user interface techniques to allow the analyst to make rapid decisions, so on. And once you have this data set, it allows you to ask interesting questions, which was not possible earlier, which is, okay, show me Rahul Gandhi's entire electoral record, all the constituencies he's won from, or he's contested from, where he's won, where he's lost, what was the margin, who were the opponents, etc. Okay, so let me jump now to another data set, which is also of interest to political scientists, which is what is happening in parliament. And one way to study this is the question hour in parliament, which is the first hour of parliament, if and when it's in session. And this both in the Lok Sabha and the Rajya Sabha. The first hour is given to these questions. So we looked at what data is available on that. And the reason this is interesting is that political scientists would like to study how does representation really work. So does the question hour in the Lok Sabha serve as an avenue for representation? Are people who raise questions in the Lok Sabha really representing people from their, maybe their ethnic group, or people from their gender, or people from their constituency, etc.? So what are the concerns that they're raising? Who is asking these questions? What is the profile of MPs asking these questions? Are they skewed, maybe towards certain party, or are they skewed in terms of age, etc.? And finally, what's the content of these questions? And overall, how does the national conversation change over time? Because this is a truly representative system where the entire country is represented at a very high level. And can we figure out anything about what the national conversation is about over time? So again, what data is available? It's in the form of a fairly loosely organized website, which again is not consistent over time. This data is available on the Lok Sabha website, but in this form where you can download, you can go click on all those links and see something like this, which allows you to browse a specific question or answer, but you can't actually compute with it. So we looked at scraping this entire website, which was easy to do, although it was kind of painful to clean it and organize it properly into columns and so on. But at the end of it, what we have is data for about 300,000 questions for the last 4 Lok Sabhas, not the current one, but the 4 before that. So this is the Vajpayee government, then 2 terms of the Manmohan Singh government, and then finally the Modi government from 2014 to 19. So these questions are selected using a random ballot. So MPs submit these questions, and the questions are selected. Some questions are selected for answering, and the oral questions are either answered by ministers on the floor or their written responses. The good thing is that since we have electoral records, we also can connect this information after, again, this kind of entity matching process. We can figure out what are the electoral records of the people who are actually asking questions. So which constituency they are from, which party they represent, what was the margin of their victory, and so on. How many terms they've been in parliament, things like that. So the first step was we just organize this data better and provide a simple searchable interface for people to browse this information with a kind of faceted browsing style. So you can find out quickly all the questions asked by a particular MP or all the questions asked of a particular ministry, etc. But further, we'd like to do some content analysis. So if this is the question, this is an example question of training to Muslim girls asked by an MP. What we'd like to essentially do is whittle this down to the subject topics that are being talked about. So, this is really about training to Muslim girls, and it's about the amount of money allocated and what's the scheme, and the fact that it's a public-private partnership or not. Right. This is what we'd really like to do. So, one of our students and subsequent staff members, Saloni, worked on applying word to vec on this data set. So she was fairly successful in finding related words. So for example, you want to query the data set of 300,000 questions for what are issues related to women, what questions to talk about women. So you'd look for not just the word woman or women, but also all these other things that you would perhaps not expect initially unless you did this kind of analysis. So this helps you classify questions better. And there's a working paper and this is still work in progress, but it's a first attempt to try and understand the conversation at a fairly high level. The next sort of data set that we would like to integrate this with is what's called who's who records of Lok Sabha members. So every Lok Sabha, and for that matter, every Vidhan Sabha in the states publishes this book when every assembly is elected with a sociological profile of who are the people's representatives. So it will have information like where they were born, what's their family background, what are their interests, what is their profession, where they've traveled, languages they know, etc., etc. So this is also interesting information because it gives a window into how, for example, what's the average literacy or average education level of legislators over time. Now, this turns out to be a pretty hard problem because this data again is not in any consistent format. It's not even available easily as PDFs. And here we're just talking of the National Assembly in Parliament. We're not even talking of state assemblies, which typically, the books would be in the vernacular, and they may be even less well organized. I'll come to a little bit of a technique for that later. Similarly, there's more data sets that we come up with. It's hard to believe, but there is no single place where you can find a list of everyone who's been a cabinet minister in India at the central level, let alone the state level. Historically, like going back in time and what portfolio they held and when they were a minister, like from what day to what day. There is no data set like this. It's a very small data set. It's only about 1,500 people, but it has to be painstakingly extracted from various Lok Sabha publications. This is again something we have put together. Even though it's a small data set, it's very high value because it enables interesting questions like, who gets to be a minister? Right, or which parts of the country are represented in central ministries? What are the electoral records of the people who are ministers? What is their experience level, and so on. So I'll just sum up with some, particularly AI or CS related research problems that are interesting in these contexts. So one is that, can we have natural language interface to legislators' data? So, we have this data set. We also do a lot of training of journalists, of political science students, researchers, even in political parties, etc., on how to work with the data. Many of them don't have data skills beyond perhaps basic Excel, right? Let alone Python or R or SQL or anything like that. So one question is, you can ask, um, you know, you have all these voice agents and you can ask them anything in natural language. So one question is, what's a good way of putting a actual data table behind it? And can I ask questions like, who contested against Narendra Modi in the last 3 elections? Um, and what was the margin of victory or something like that. So natural language interfaces, which would be very interesting and very helpful for researchers and journalists and so on. Extraction from very messy data templates. So like the who's who that I mentioned, even if you extracted all the text from it, it's very loosely formatted. There is no schema as such. So um, can you kind of combine machine learning and um, uh, maybe other techniques to try and extract data in a relatively clean and tabular form? So Sriram Rajamani and others at MSR have done some work using our data set of the who's who to try and extract fields of different legislators' who's who records. Entity resolution and disambiguation. I mean, if you look at the literature, it seems like a solved problem, but if you actually try and use these tools in practice, you'll find there's still a lot of work to be done there. Automatic detection of anomalies or likely data errors or likely patterns that would be interesting for people to study. That's another area. And finally, one thought is how can we redesign or repurpose poorly designed government websites to make them easier to browse and extract information from? So today, if I'm visiting, let's say, a Portuguese language site, my browser will automatically translate it for me and show the site to me in a language that I know. The question is, can we do some kind of automatic um, repurposing of the content on a site to make it easier to browse? So that this is a challenge that I've been um, posing to my students for a long time, but no one has actually managed to crack this problem yet. But I think it's a really interesting and important problem to work on. I think I'm almost out of time, so I will quickly maybe jump to other data sets. I was going to talk about spending data, like to do with, you can apply similar analysis for, let's say tender information. So all the tender information is in the public domain because of the procurement acts that are ubiquitous in India now. But they're so poorly organized that it's impossible to get the information, let alone do anything with them. So, for example, you'd like to ask, okay, show me all the tenders for ventilators that were ordered, and can we figure out what the average price is, and figure out if there are notable discrepancies from what the average price is, and that may, help in transparency or putting a spotlight on where money is being misspent, etc. Right. So a couple of other projects I'll mention. Mapping the bureaucracy. Again, it's a small data set. If you look at all the civil services officers, but it's a very high value data set. Mapping administrative and electoral outcomes tends to be not easy because the census operates on administrative boundaries like districts, and the electoral data is not on district boundaries. It's on on electoral constituency boundaries, which don't align. We're hoping to work on mapping the judiciary, who the judges are, where they come from, what can we say from the judgments that they write. Agriculture, I mean, there's a lot of heat and noise right now about agriculture and the farmers' protests, but if I want to go to one single place where I want to understand how much does every state produce and what has been the historical support price for each crop, that data is probably there somewhere, but it's not in a way that I can look at and get an aggregate picture. Certainly not get a historical picture. And finally, content analysis for archival data. So there's other kinds of analysis that political scientists want to do, such as, what is the level of violence in a given society, and how that's reflected. So if you could analyze long-term newspaper archives, you could try and plot that. So with those sort of interesting and hopefully intriguing questions, I will leave you with these takeaways. I'd encourage the students and other researchers to reach out to people in public policy, political science, economics, because there's a lot of high value information that they have that can probably benefit from all the new techniques in CS and AI and ML. And it's a great area if you're looking for a PhD topic or you want to do some exciting work. This can be a very good thesis topic. So with that, I'll stop and take any questions.
Okay, thanks a lot, Sudhendra. That is a fantastic and illuminating talk. Like, what kind of like rich data can we actually get? So there are a couple of questions from the attendees. So let me actually just take those questions of let tell you the questions. So the first question was, I think it's about data, like what data is available, that whether the attributes like gender, caste, etc. of the candidates are available along with the wealth distribution in the data set that you collected or planning to collect.
Yeah, gender is definitely available. Wealth distribution is available from 2004 onwards because the affidavits only came in 2004. Caste information is available for some states. This is not actually publicly released. It's gathered by our students and field researchers. We are happy to provide it for serious research use. That's one variable that we don't put out in the public domain.
That's very responsible in some sense. So the second question, I guess, a little bit controversial. So let me actually take a third and they'll come back to a second. So third question is, are you looking at any questions about understanding the Indian electoral process which may benefit from AI or ML? For example, delimitation of constituencies, understanding second choices of voters or potential of alliances between parties and so on. So understanding the election process are looking into it.
Yeah, it's those are fascinating questions. I'm afraid we are quite far away from that level. Like I said, it's even hard to get delimitation maps of the current current boundaries right now. I do think though that there is scope to do good work in that area, and perhaps in some cases, in some states, we may be able to get the data. We may be able to even perform some experiments around it. Second choice, for example, I mean, maybe you can't do it in the electoral context, but you can do it in other contexts, other kinds of participatory voting, etc. So there is I think a lot of interesting scope. Unfortunately, in India, I think we are far away from any of that becoming a reality. But certainly, from a research perspective, it's quite interesting.
And the controversial question was, can you predict future election results? Which can have a 1 hour discussion on this. So if you just want to quickly address that, that is fine. Otherwise, we can take this offline.
No, we are not psephologists. We are very clear about that. We don't even do surveys. We can tell you all about the past election. We can't tell you anything about the future.
Perfect. So one last thing, I guess this is now open to panelists. So one panelist was really intrigued by your talk and wanted to ask. So, Animesh,
hi, Sudhindra, Animesh here. Can you hear me?
Yes.
Yeah. So I was just wondering, if this kind of data could be also augmented with the social media data, like Twitter handles of the politicians or the bureaucrats that you are looking into. So do you think that that could be an interesting direction of research and could give additional benefits to the data that you are building?
Certainly. So, I talked about, Parliament is only one way that representatives express themselves, right? I mean, nowadays, in fact, you would argue that social media is more current and more representative of what they're really thinking. So there have been projects. I wasn't able to attend Georgie's talk yesterday, but he's been doing work on that. I know there are other people who have also done work on archiving tweets. In fact, we have a tweet database of some sort, which we haven't done much with of politicians. But definitely that's a very interesting area as well.
Okay.
It's also interesting to study, just how politicians are engaging with their constituents on social media. So
Oh,
there has been some initial work on that. I haven't seen anything very interesting, but clearly that's happening already in the field. I don't think anyone understands how it's working
yeah.
yet.
Yeah. So just to actually end on this note, I guess there was some work on how during Brexit, the politicians tried to engage with their constituents in UK. But yeah, absolutely right. I mean, that seems like a field that is extremely rich and very impactful to that end. Okay, then. So on that note, let's move on to our next and final talk. So we already have within us the next speaker. So our next speaker is Dr. Milind Tambe. Milind Tambe is Gordon Mackay Professor of Computer Science and Director of Center for Research in Computation and Society at Harvard University. Concurrently, he is also Director for AI for Social Good at Google Research India. He is a recipient of numerous awards and accolades, both from academia and government. Actually, I tried to note that down, and then I just realized that it will take a long time to read all of them. So he's extremely well known in the field. And Professor Tambe is also a fellow of IIII and SCM. And today, in this last talk, Professor Tambe, Milind is going to talk about advancing AI for social impact, learning and planning in the data deployment pipeline. So without further ado, Lynn, the stage is yours.
Milind, you are mute.
You're on mute. Yeah.
Yeah. All right. Well, thank you. Thank you very much. Hopefully you can hear me now.
Yeah,
Yes.
all good.
All good. Thank you. Well, thank you. Thank you for inviting me, and really appreciate very kind introduction. So I'm going to be talking about AI for social impact. For the past 15 years or so, my research group has been focused on advancing AI and multi-agent systems research for societal impact, focusing on areas such as public health, conservation, and public safety and security. The key challenge we focus on is how to optimize our limited intervention resources. With respect to public health, the challenge is that we have a large population to serve, but limited number of social workers or public health resources. Concrete example is work we've done with youth experiencing homelessness in Los Angeles. Harnessing the social networks of these youth, we are able to show that our influence maximization algorithms are far more effective in spreading HIV information and reducing HIV risk behaviors compared to traditional approaches. The technical areas I'll focus on here are social network algorithms and bandit algorithms. With respect to conservation, we have large conservation areas to protect limited number of ranger resources. Concrete example is work we've done in Uganda and Cambodia. Harnessing past poaching data, we are able to predict where poachers set traps or snares. And for the past several years, have been able to remove a large number of these snares, hundreds or even thousands. The technical area I'll focus on here is green security games that combines machine learning and game theory. With respect to public safety and security, we've contributed a new model called Stackelberg Security Games and contributed new algorithms that have been used by security agencies in the United States, such as the US Coast Guard, assigning air marshals to flights, and others. Today, I'll focus on public health and conservation as the two topics, which are also the focus of our work at Google Research India. We've been working with several nonprofits. Given the limited time, I'll focus on one of those projects with a nonprofit called Arman. In all of these different projects, you'll see three common themes: the use of multi-agent systems research, whether social networks or game theory. Second, a data to deployment pipeline that starts with immersion in the domain. We work with the nonprofits to understand the kinds of data they have, the challenges they actually faced. Following that, given their data, we make predictions based on a machine learning model on which of their cases are predicted to be high risk versus low risk. Now, we cannot intervene on all of the high risk cases. As I mentioned, we have limited resources. So the multi-agent reasoning algorithm tells us which cases to actually intervene on. And what's important to us finally is to field test and deploy our algorithms, not only because we want to understand the limitations of our models and algorithms, but also because we are doing AI for social impact. Social impact is a key objective. If we don't achieve that, then it's not really social AI for social impact. Secondly, we are supposed to be swimming in big data, lots and lots of data everywhere. But in these kinds of domains, often working with marginalized communities, lack of data is a norm. We can't complain that the data is not quite in the right form or there's not enough of it. Dealing with this lack of data must be part of our project strategy. And you'll see this theme throughout. Finally, all of this work is only possible because of the interdisciplinary partnerships with the governmental and non-governmental organizations around the world, whether it's homeless shelters in Los Angeles, wildlife conservation organizations around the world, or other nonprofits in India. Our work is in service of the inspiring work that these nonprofits are doing. Ultimately, we want to empower these nonprofits to be able to use these AI tools and avoid being gatekeepers to this AI technology for social impact. So with that introduction, let me go on with the public health as the first topic I'll focus on. Here I'll start by looking at information dissemination and behavior change. I'll cover papers from 2017 to now, 3 years at conferences such as AMAS, AAAI, NeurIPS, others. I'll highlight the role of the key PhD student and postdoc who led the work by putting up their picture in the top right-hand corner of the slide on which their work is shown. So let's start with the first topic. The motivation here is preventing HIV amongst homeless youth. There's unfortunately 6,000 youth who sleep on the streets of Los Angeles every night. The rates of HIV amongst this population is 10 times the rates of the normal house population. We cannot communicate about HIV risk to all of these folks directly. Instead, homeless shelters carry out a social network-based campaign. So they'll invite peer leaders into the shelter, educate them about HIV prevention, and then expect the peer leaders to talk to their friends to talk to their friends, and information to spread in the social network. This is a face-to-face interaction. This is not being carried out through Facebook, etc. This is the classic problem of influence maximization in social networks in computer science. Given a social network graph G, we have to choose K peer leaders nodes in order to maximize expected number of influence nodes. Here, we assume information spreads via this independent cascade model. I talk to a youth A talks with, spreads this information with some probability to an adjacent youth B with some probability spreads it to some adjacent youth C, and information cascades in the network in this fashion. If we take these algorithms and directly apply them in our context, we see 3 key challenges. First, there's uncertainty in the exact propagation probability over edges. We don't quite know this probability. Second, we can't recruit all of the peer leaders all at once because of capacity limits. So we end up recruiting them in batches. Unfortunately, not all of them show up. That means the second batch we invite has to take into account who showed up in the first batch. So we need a multi-step dynamic policy. And finally, the social network itself is not known. So we can sample the network by querying a limited number of youth with a limited query budget. I'm going to address these challenges going in the next few minutes. I'll start with the assumption of full social network being known in addressing the first challenge and work my way downwards towards the case of the unknown social network. So first, the uncertainty over propagation probabilities. Traditionally, when we talk about influence maximization, we say, if we talk to a youth C about HIV prevention, then there is an adjacent youth D. We know the probability with which information will propagate from C to D. But immersion in this domain clearly showed us that this probability is not known exactly. So we can model this as being sampled from some distribution. Unfortunately, the mean of this distribution itself may not be known exactly. So we can model the mean as lying within some interval. So now we have this problem of influence maximization with uncertainty. To address this problem, we can cast this robust influence maximization as a game against nature. So our algorithm is trying to choose peer leaders to maximize influence, and nature is trying to choose parameter settings to cause our algorithm to perform as worse as possible. So we are trying to find a maximum strategy with us maximizing and nature minimizing, where the payoff is the ratio of the outcome of our policy of a choice of a particular set of peer leaders to the optimal that would be possible if the parameters were known in advance. The Amos paper talks about mixed strategies and pure strategies in this game. If you want to know more, you can look at that. Let me give you intuition of how this game is solved. So along the rows are our policy choices. If you imagine a network of 400 youth and we are choosing 40 peer leaders, we have a 400 choose 40 number of policies along the rows. Nature is choosing parameter settings along the columns. Nature is choosing from a continuous interval. So you can see that this is a massive scale game with a very trillions of possibilities for our policy choices, and obviously massive number of choices for nature. So we cannot represent this game in memory, let alone trying to solve it. So we solve these problems by using a double oracle approach. This approach starts by initializing the game with some small number of policies and parameter settings for nature. And then in an iterative process, basically influencers oracle will now add a best response policy. Then nature's oracle will add the best response set of parameters, and the game grows. And we iterate in this fashion until convergence. And we show that we converge with approximation guarantees. And empirically, we can converge with just a small number of iterations. So we can arrive at the equilibrium strategy with a small expansion in the original game. So this is how we can solve for robust influence maximization, finding the policies that are robust in terms of choosing peer leaders. Next, we need a multi-step policy. As I mentioned, we can't bring in all 40 youth. We have a small homeless shelter. So we may bring in 4 youth at a time. Unfortunately, we call the 4 youth. Well, these are youth under difficult circumstances. One of them may not have the bus fare to come to the shelter. One of them may choose to run away. So the youth that show up are not the youth we called. So when we call the next set of youth, which are shown in green, we have to take into account the 3 youth who actually showed up in the first time step. So this is, and the state of the network itself is not known. So we have action uncertainty and we have observation uncertainty, which people may recognize as a problem ideally suited by solving with a PALM-DP. So we choose a set of youth to invite. Some subset of those may show up. Based on who showed up, we choose the next set of youth, all the while the state not being seen. Unfortunately, solving these problems with PALM-DPs in general is difficult. And so one key idea then is to understand from the immersion that these communities have several sub-communities, youth who play basketball together, youth who hang out on the Venice beach together. And so we can partition the network and then solve sub-problems more efficiently. The third problem I mentioned is that we don't know the social network. So you can imagine going to the homeless shelter, talking to every single youth in the shelter, and then generating their full social network. This is very difficult. Instead, if you can sample just 20% of those youth, you query a small fraction of these youth to get a small sampling of the network and then solve this influence maximization algorithm, that's far more doable. So the input to the algorithm is the set of nodes, the youth in the homeless shelter. We have a budget, how many youth we can query. Having queried them, finding sampling of a social network, we have to output the K peer leader nodes that will spread influence such that the total influence spread is similar to optimal possible if you knew the full social network. To that end, we sample nodes randomly and estimate the sizes of the communities they belong to and choose seeds from the largest K communities. In our AAAI 18 paper, we provide some theorems for the performance of such an algorithm. Now, I've talked to you about network sampling, about robust policy and a multi-step policy. We put it all together in a system called Sampling Healer, and it's going to tell us which peer leaders to select, and then based on who showed up, tell us the next set of peer leaders to invite. So if it's a total of 40 youth, we may bring them 4 at a time or 8 at a time, etc. Now it was time to actually test this in a pilot test in practice. So we recruited 230 homeless youth. 60 of them were in the sampling healer condition. That is, the network was not known. We sampled the network. 60, roughly 62 were in this healer condition. It's exactly the same as sampling healer, but the full network is given to the algorithm in advance. Healer plus is a variation of healer. Degree centrality is the traditional approach. Bring in the most popular youth, the highest degree nodes. This is what the shelters actually use. In each case recommended by the algorithm, we invited 12 peer leaders, 4 at a time. And here's a picture of our social work colleague educating the youth about HIV prevention. So in every one of these conditions, the same approach was used to educate these youth. And then we waited a month and want to check at the end of the month which algorithm was most effective in spreading HIV information. And here's what we find. Degree centrality, the more traditional approach, reached 25% of the non-peer leaders, the people that we did not invite. Only 25% of those got informed with degree centrality. With Healer and Healer Plus, 75% of the non-peer leaders got informed. So the AI algorithms were far more effective in spreading HIV information. But as you can see, sampling Healer reached just about the same as Healer. So even though the network was sampled, it was just as effective. In fact, you can see it being a slightly more effective, and that's just a particular feature of that experiment. But in a sense, what we see is that the sampling Healer algorithm is performing much better than the traditional approach of degree centrality. So now at this point, it was time to conduct a large-scale experiment. And this here now, our social work colleagues were not interested just in figuring out how many people got informed, but whether they actually changed HIV risk behaviors. And so this was a study that was conducted with roughly 750 youth. This is work done in collaboration with Professor Eric Rice of social work. And as far as we know, it's the first large-scale application of influence maximization for public health, conducted in collaboration with 3 homeless shelters, My Friend's Place, Safe Place for Youth, and Los Angeles LGBT Center. We tested, there were 3 arms to the study. First, sampling healer, our algorithm. Second, degree centrality, the traditional approach. And third, no intervention at all. And so we recruited youth according to these algorithms, obviously none in the no intervention case. And then we waited a month to see what changes in behavior occurred. Then we waited 3 months, again checked what changes in behavior occurred. And what did we find? At the end of 1 month, we can see that in terms of sampling healer, there's more than 30% reduction in condomless anal sex and HIV risk behavior. With degree centrality and the control group, there was no change. So clearly, sampling healer was able to significantly reduce this HIV risk behavior in the population of the 250 youth or so where it was being deployed. When we come to 3 months, we can see that degree centrality has begun to catch up, but still not as good as sampling healer. The fact that sampling healer was able to reduce HIV risk behavior faster is important. First, because it's a risk behavior, so getting it reduced faster is important. And secondly, this is a community where youth come and go, and therefore having this information out there faster is important. We also looked at other HIV risk behaviors, condomless vaginal sex, and again we can see that sampling healer is much better than these other methods. So this is clearly being appreciated by our partners, as you will see here.
Beautiful way to kind of like marry this tech world with this social service world, like, and how we can kind of go deeper and impact young people and elevate them.
If this group became a really big thing, it could really help out a lot of youth.
So today, in collaboration, for example, with Ravindran and his team at IIT Madras, we are extending this work using reinforcement learning, trying to do the same network sampling, but using reinforcement learning and showing, at least in simulation, it does better. But what remains very exciting now is to test these algorithms in practice. So far I've talked to you about HIV prevention. Let me now switch to another application, which is suicide prevention. This is work basically involving gatekeeper selection. These are youth who we will recruit among the homeless population, or say campus population in a university community, where the gatekeepers will keep an eye out on their peers. They're given special training to look for traces of behaviors that may indicate a need for counseling. For example, a student or a homeless youth that says, sometimes I want to sleep and never get up. A gatekeeper, a trained gatekeeper, may pick up signals like these and recommend to this youth to talk to a counselor or get a counselor to talk to this youth. So we select a few gatekeepers in the full community. So this is very much like a problem of graph coverage. However, not all gatekeepers we select will show up to do their work. Uh, they may have other challenges. So therefore, this becomes a problem of robust graph coverage. So we want to select gatekeepers, maximizing the worst case coverage if some gatekeepers do not show up. We took the latest in robust graph covering and applied it to our real world networks. And what we found is that there's disparity in coverage across racial groups. So some groups, for example, the white group may have much more coverage than some other groups. To address this challenge of disparity in coverage, to ensure fairness, we've checked we have worked with different approaches: max min fairness, diversity constraints, which is inspired from cooperative game theory. But in the latest AAAI 21 paper, we point out that instead of giving point solutions, each of which embodies some trade-off, it is better for a policymaker to have the tools of trade-off in their hands. So we give them a parameters which they can change to get to the right trade-off between fairness and performance that they desire. So now let me switch over from social networks to health program adherence. And given the limited time, I'm going to go through some of these at a faster rate. Of course, I'll be very happy to talk later after the presentation. So the first challenge here is work we are doing at Google Research India. This is focused on maternal and child care. As you know, a woman dies in childbirth every 15 minutes in India. 4 out of 10 children are too thin or short. We are very privileged to work with a nonprofit called Arman, which works with 18 million women in India and has 160,000 health workers that they work with. One of their programs is called M-Mitra. Basically, every week they give a call to a new or expecting mom which is enrolled in the program. It's a friendly 3-minute message in the local language, Marathi, Gujarati, etc. It's a friendly message in the voice of the local health worker. So it'll be something like, you are in the 6th week of pregnancy. You should use this health supplement. Your child is 3 months old. You should enroll them in this government program. And they have shown in randomized control trials that women who listen to the 150 calls which Emitra has, there's significant benefit to the health of the mother and the baby. 2.2 million women have enrolled in Emitra so far. Unfortunately, we find that significant fraction of these mothers enroll and then eventually become low listeners or drop out of the program. Up to 30% may thus drop out and not benefit from M-Mitra. Arman's choice then is to wait for these women to drop out and then try to re-recruit them back. Could we predict in advance who's going to drop off and stop them from dropping out? This is again work done with Ravindran et al. At IIT Madras. So we are trying to predict beneficiaries likely to drop out. And so here's how this is supposed to work. This is mother number 1. We give her an automated call from Arman, but she didn't pick up the phone in week 1, but she does pick up the phone in week 2, week 3, week 4, and week 5. Mother number 2 picks up this automated voice call in week 1, week 2, but not in week 3, yes in week 4, but not in week 5. And so on for hundreds of thousands of women who are enrolled. Now it turns out that mother number 2 and 4 eventually dropped out of the program. If we could point out to Arman ahead of time that mother number 2 and 4 are the one at the highest risk of drop off at the end of the 5 weeks itself, then Arman can focus on them. They can call them, they can send health workers to the homes of these mothers and ask what was their difficulty and resolve it so that they remain enrolled in the program and do not drop off. So this is what we have done. There's a system that makes these predictions. We did extensive tests with past data from Arman. And then it was time to do a pilot test, which we did with 18,000 beneficiaries enrolled in Arman mothers, expecting mothers, in November and December of 2019. And we made predictions as to who's at high risk of drop off. And what we found in January through April of 2020 is that our predictions were very accurate in terms of the recall and precision being higher than zero 0.8. And so now it was time to actually deploy it. So the system is now deployed with Arman today. I'm very happy to note that Arman is using these predictions to actually make phone calls, and up to 30% of women going who are going to drop out are actually being retained in the program. So they figure out who's going to drop off and then do a live call to understand why the women might be dropping out and resolve those conditions such that the women stay in the program. So this is really very exciting, and we are trying to expand the scope, eventually hopefully reaching the 18 million women that Arman is working with. A similar challenge, of course, exists with tuberculosis prevention. As you know, tuberculosis is obviously a massive worldwide challenge, but in India causes 500,000 deaths a year and 3 million people are infected every year. One big problem is non-adherence to TB treatment. People are supposed to take this medicine for 6 months, but due to side effects and other challenges, people will start taking their medicine and drop off, which is a problem not only for themselves because they don't get as well, but also it creates more drug resistant bacteria. So the challenge then is to make sure that they keep taking their medicine. So there's this digital adherence technology now that gets employed. You may know it as 99 dots. So for example, behind each pill there's a phone number. You open the pill box, there is actually a random phone number. It's not known to the patient in advance, and they're supposed to call that phone number to let the health worker know that they're taking this medicine. So health worker can see who's been calling, and if somebody doesn't call for 3-4 days, then they know this person is about to drop off, then maybe go to their home or do something to try to retain them, to keep them taking their medicine. But of course, this means that the patient has already missed a bunch of doses. Could we intervene on the patients before they miss doses? And again, using the same kind of machine learning based prediction on the phone calls, we are able to make predictions of risk of adherence, people who are going to be not adhering from the phone call patterns. So working with a nonprofit called Everwell with data from Mumbai with 15,000 patients and 1.5 million phone calls, we are able to show that our algorithm is more effective than their rule-based approach in predicting the number of true positives and reducing the number of false positives. And we're going through IRB approvals and so forth to try to deploy the system in practice in Mumbai. So far, I've talked to you about prediction. Now let me switch to prescription, which actual patients to intervene on, or which moms to actually intervene on. So here's the situation we face. We have a large number of patients that have been identified as high risk. Maybe 200 patients are identified as high risk. Now we have to figure out which patients to call every day to remind them, hey, you got to take your medicine because you're a high risk patient. So you can imagine a health worker who has 200 patients under her care and has to choose the 5 patients she's going to call every day. So she may say, okay, I'm going to call the first three patients here. Let's say she can only call three patients. Two of them may say, I took my TB medicine last night. One may say, I did not take my medicine. Now she has to decide the next day which patients to call based on the information she received. She may choose these other three patients. Again, one of them may say, I did not take my medicine. Two others said, I took my medicine last night. Again, she has to decide the next day. And you get the idea. This has to go on for 180 days, which is the total time that a TB patient is enrolled. In fact, the health worker has to do it every day for 365 days a year. So how do they do it? Today, when we checked in Mumbai, we understand that they do it in a round robin fashion. So they'll just call patients, first 10, then the next 10, then the next 10, and so on and so forth. But this is inefficient because you can imagine somebody's taking their medicine every day, then calling them again and again is not as good use of our time. And there may be another patient who really needs that reminder more frequently, and they are only getting a call every X days. It's better to get them a call more frequently. So how do you decide which patients to call? This, as you can imagine, is a bandit style problem, and we've cast this as a adherence restless bandit. So each arm of the bandit is a patient with a binary latent state. They're either adhering, they have been taking their medicine, or not adhering. And so we have a new algorithm based on this restless bandit, which is presented at NeurIPS 2020 and follow-up papers at AMAS 21 to generate policies using this restless bandit framework, which tell the health worker which patients to call every day. Again, since we may be running out of time, I'm going to just skip to the results. We are able to show that this algorithm, which is shown here in blue, is much faster than the state of the art, which is shown in orange. And as you can see, in terms of solution quality, blue loses very little in terms of solution quality. So I'm going to end this section on public health by talking a little bit about our work with COVID-19. We started this work in March. There's a paper at the Proceedings of National Academy of Sciences, which talks about our agent-based model, which models families, comorbidities, and so on and so forth. When the paper was being written, the US states of Georgia and Florida were trying to figure out whether to lift the lockdowns. And so when we wrote the paper, we got coverage in different news media, including CNN, talking about the impact of our model in terms of what it was predicting, the number of infections and so forth. But the more recent work that we've been doing, which got published in Science Advances, looks at COVID testing policies. Today, we have tests like PCR, which are gold standard tests, highly sensitive tests, which can detect viral concentrations at very low viral concentrations, but the cost is much higher, and it takes about a day to get the results back. On the other hand, we have antigen strips, which are less sensitive in the sense that we need higher viral concentrations, which are cheaper, but the tests come back in 15 minutes. So if you're Harvard and you're trying to see what test should I deploy to test students every day or some days of the week in order to reduce infections, should I be going with the gold standard test, the PCR test, or the antigen tests? And this might be the case in other factories, on your own campuses. And so we did this modeling and found out that if we were able to do these tests, the less sensitive and more sensitive, at the same frequency, every 3 days we test every student. And then the students who test positive, we isolate. If we are able to do this frequently, and if the test results come back instantaneously, then yes, the more sensitive tests are better. But if there's a day's delay in getting results back, which happens with the more sensitive tests, then suddenly all the benefit of the more sensitive test is lost. On the y-axis is the number of infections. Higher is worse. So even a 1 day delay in getting back the results, meaning 1 day delay in isolating patients, means that the advantage we got out of the more sensitive test is lost. And then because the more sensitive test is more costly, we may be only able to run it every 5 days instead of every 3 days. Again, the benefit of the more sensitive test is lost. So our Science Advances paper basically says that test sensitivity is secondary to turnaround time and frequency. turnaround time, getting the results back in 15 minutes, and frequency, running the tests more frequently is more important than test sensitivity for COVID-19 surveillance. This work got attention from the World Health Organization in terms of diagnostic testing. It got covered in New York Times, etc., and allowed for our epidemiological collaborators to advocate to the US FDA and CDC to push for more tests being supplied across and across the US for this these antigen type tests. So in the remaining 7-8 minutes or so, I'm going to touch upon the work that we've been doing in the area of conservation. And I'll go through this relatively quickly so that we have time left for questions. So in national parks around the globe, like the Queen Elizabeth National Park in Uganda, there's the wonderful, magnificent wildlife, but there's threats to the wildlife from poaching. Snares or traps that get placed, hundreds or thousands of them every year in order to maim and kill this beautiful wildlife. As you can see, rangers then search, and you can see it can be difficult for a ranger to search these forests, trying to look for these traps hidden in grass. So how can we help these rangers? We cast the problem as a Stackelberg security game. So basically, you can imagine dividing up this park into 1 kilometer by 1 kilometer grid square and recommending to the rangers which areas to actually patrol. Each grid square is a target. Areas with more water, there's more animals, more important target. Other areas, less important. So for those unfamiliar with the Stackelberg security game, you can imagine this is a game where the ranger is playing in the rows. If the ranger always chooses one particular area to protect, the poacher observing where the ranger is going will go to the other area. So if ranger goes to area 1, poacher will go to area 2, getting a positive reward. So the ideal recommendation to the ranger is to patrol these areas in a randomized fashion, a mixed strategy. So um, generally, previous work in Stackelberg security games. Now, of course, I've shown it to you as a 2x2 game. As you can imagine, there's hundreds of thousands of these squares. And so this is a very, very large scale game. So traditionally, Stackelberg security games have assumed a fully rational adversary, a strategic adversary. Instead, here in the case of poaching, we are faced with boundedly rational poachers, which means that we have data from past poaching activities, and we can learn the adversary's response to our patrolling strategy from their past behavior. So we learn adversary response model at each target I. So basically, from past 14 years of poaching data, we can predict the probability that a poacher will put a snare, a trap, in a 1 kilometer by 1 kilometer grid square based on features such as ranger patrol frequency in that grid square, animal density, distance to rivers, roads, and villages of that grid square, and so forth. And indeed, there's an ensemble approach that allows us to make these predictions. The first test of this approach was in Uganda, where we made these predictions of 2 9 square kilometer tests in a pilot test that was pointing the rangers to newer areas that they hadn't patrolled before. This is shown with the green dots, which you can see doesn't overlap with the red dots. The red dots are where the rangers had previously found traps or snares. Now we are asking the rangers to go to new areas that they haven't patrolled, shown in green, and we are recommending to them, you are going to find snares in these places which you haven't patrolled. This happened to be a 1 month before the AMAS conference deadline, which meant that as the rangers patrolled, and if they found snares, we would be able to write a paper. If no, then we will not be able to write a paper. And so every day the rangers would report to us what happened, and what they initially said nothing, but finally they found a poached elephant with its tusks cut off. We were too late to save this elephant, but at least the machine learning system was pointing us in the right direction. Then came news that they found a whole elephant snare roll and removed it. So poachers were active in the area. They were killing elephants, but before they could kill the next set of elephants, a whole elephant snare roll was removed, thus potentially saving lives of elephants. And then whole antelope snares were removed. So this pilot test was seemed to be a success, and now it was time to do a larger scale test, which we did with 3 parks: Queen Elizabeth, Murchison Falls in Uganda, Sri Park Wildlife Sanctuary in Cambodia, where we made predictions of 24 areas. Some we made predictions. These are all areas which were infrequently patrolled. There were these areas, several of them we made said, you're going high risk areas, you're going to find more snares. Others, we said low risk areas. You're not going to find many snares there. And then rangers went out, patrolled these areas for 6 months. And where we predicted high risk, indeed more snares were found. Where we predicted low risk, indeed less snares were found. Across these three parks, hundreds or thousands of these snares were removed. In fact, the number of snare captures jumped fivefold in Cambodia, from 100 snares to more than 500 snares as our system was deployed in the Sri Park Wildlife Sanctuary. So this is very exciting. I'm going to skip over some of these details as I see that we are just about to run out of time. Pause, the system that we've built is going global to many different parks around the globe. Um, and the final system I wanted to talk about is the system called Spot for automatically detecting poachers. And so this is work done with a nonprofit called Air Shepherd, which flies drones. They send infrared videos to a van, and the job for us is to figure out from these infrared videos if we can automatically detect poachers and wildlife. So we built a system called Spot, delivered it to Air Shepherd to detect these poachers and animals. There's some exciting work here in signaling to be done. But again, in the interest of time, I'm going to skip through all of this work on signaling games and come to the end. Pause, as I mentioned, is going global. The system for making predictions in collaboration with several with these conservation agencies for wildlife protection, WWF, WCS. We've made it available to hundreds of national parks around the globe. It's being downloaded, being tested. It's a very exciting time in being able to apply AI for wildlife protection. So with this, I'll end by some key lessons. First, it's important to note that achieving social impact and AI innovation go hand in hand. It doesn't doing AI for social impact doesn't mean you're giving up on AI research. In fact, you're enabling very interesting AI research. It's important to take a data to deployment pipeline perspective. The work is not just about improving algorithms, but it's about going all the way from data to deployment. It's important to step out of the lab and into the field, to embrace interdisciplinary work with social work and conservation, to deal with the fact that lack of data is the norm. We don't have an exact patient state. We don't have a social network in hand, but deal with it as part of the project strategy as a new research. And final point, and that's the end of the talk, our ultimate goal is to empower nonprofits to use AI tools directly and to avoid being gatekeepers to AI for social impact technology. With this, I'm going to end my talk and open it up for questions. Thank you.
Thanks a lot, Milind, for like excellent talk, and just which clearly shows that how much AI can help for impacting our society and making it better. So we have one question so far, and it was more technical, like what kind of neural networks are used in prediction of dropouts? I guess this is in connection to your study for the medicine in India and also in US.
So the TB prevention work we used LSTMs, but it also combined it with other features. And you can see the work in KDD 2019 where we outline some of this work. The part that I didn't get to talk about as much is something called decision focused learning. Essentially, the idea is that we are making these predictions in order to accomplish certain interventions. So we can make predictions of who's at high risk of drop off, but then we have to intervene on them. We have to send health workers to their home, etc., in order to get them to remain in the program. And so decision focused learning basically changes the objective, changes the loss function, so that it's not just accuracy of prediction, but it's the actual objective, which is intervention to stop people from dropping out. And so we have shown that this decision focused learning leads to higher total utility than simply focusing on accuracy. So you can see this in KDD 2019.
Uh, Thanks. So here is another question just posted now. While prediction of influential nodes to maximize influence, are you also considering negative influence of some nodes?
That's an excellent question. in this work, we are only focused on one-sided influence. That is that we educate youth about HIV prevention, and then they spread the information about HIV prevention. There is not a counter narrative that tries to stop this information. But if you imagine, there are other domains where this competing influence is important. For example, as the COVID-19 vaccine starts to become available, there is the anti-vaccine group that is going to spread information to people to not take the vaccine. So in these cases, it is important to do this competitive influence maximization. And that's a very important topic. We've done some work in it, but this is not important. This is not as relevant to the HIV prevention case.
Okay. I guess this is the last question. The question is, I have the attendee told, like, I have come across papers on NLP to fight social biases and stereotypes. Can you explain the methods on how NLP can help fight social atrocities? I think this is a high level question, but if you want to comment on it.
No, it's a important question. It's not an area that we focused on. If I understood right, the question is NLP to prevent social atrocities, and so we have not worked on it ourselves. With respect to public health, some of my colleagues have worked on using natural language understanding to try to address some of the social challenges that come up. But so I mean, even something like, when President Trump talked about, hey, why don't people inject bleach in order to fight COVID-19? They showed that actually, on right after that, there was a lot more search on bleach, for example, and then immediately after that, a lot more search on poison control, meaning people were ingesting some of these products and therefore and then or trying to deal with poison control. So there is there is a lot to be done. It's just not a topic that we have focused on ourselves.
Okay, uh, thanks a lot. So I can see like there are one or two more questions from attendees, but in the interest of time, let's take this offline and feel free to. I'm pretty sure Milind will be happy to talk about if you have more related questions. So I guess from panel members, we had one questions to you. So I'm handing the mic over to panel.
Oh, uh, thank you, Professor Tambe, for this great talk. This is Niloy. Yeah.
Hi.
So, so about your this near uh, uh, project, so you have done it in various parts of the world. It's not only one part of the world. So how does the parameters change when you go from one part of the world to other part of, because there are climates that change and the vegetation is different. So does the same model work, or you have to build up different models for different places?
Beautiful question. Beautiful question. I can tell you a quick story so to illustrate that parameters have to change. So we worked in Uganda. Land is flat, and so we could tell the rangers to walk across, and it from point A to point B, and it worked. Then we generated similar patrols from Malaysia, and then we will send them patrol routes, and they would keep saying this doesn't work. And we were saying, what is wrong in Malaysia? And they said the shortest distance between 2 points is not a straight line. To us, this was extremely confusing. What is different in geometry in Malaysia? So we flew down to Malaysia, we patrolled with the rangers there, and we suddenly realized that this is not flat land. It's a highly hilly area. So if you tell people go from point A to point B in a straight line, that means they have to go climb down a mountain and go up a mountain, and it's very difficult. And so what you have to do is to walk along ridge lines, walk along river beds. There is a interesting road network inside the forest, and you have to use that rather than just telling people go straight, which was okay in Uganda, not in Malaysia. And so to your question, we have to adapt country by country, park by park. And so the predictions are specialized per park. The patrol routes have to be specialized per park. There's some very interesting challenges here about transfer learning and so forth, which we also need to deal, which we have not dealt with. because there are parks which have very little data, parks that have a lot more data. So far, the parks we have dealt with have been ones which have been intensively patrolled, the Queen Elizabeth, Murchison Falls, and SWS in Cambodia, and therefore we have escaped some of these challenges. But it's a very interesting question. It's there's a lot that we need to do in terms of further research to protect wildlife across the globe. And I welcome collaborations in this area, because obviously it's also a challenge in India, and we would love to collaborate on that.
Anyway, your work is really inspiring for all of us. Yeah.
Thank you, Niloy, for those kind words.
Sounds good. So with this, we are closing this session and closing IndoML. So a few parting words from Niloy, perhaps, from the organizing committee. You are muted, Niloy. Niloy, you are muted. Um, ah,
Hello.
yes, we can hear you now. somehow got muted.
Yeah. So I think we have come to the end of this program. So yeah, thanks everybody for participating in this, and I hope the effort which primarily IIT Gandhinagar, Mayank, Udit, and Anirban put forward, and me and Animesh, maybe all of you can come on the video if you can. That me and Animesh also helped a bit, and I guess the topic was so which we chose, AI and science, and was very interesting, and it gave a lot of points. I learned a lot of things, and I hope everybody in the audience have learned a lot of things. And we plan to continue this, and maybe next time we will have it in a more physical space. Although if we have this in this space, perhaps we are reaching more people, but physical space may be a little more warm. And also I would in the end also want to thank all the volunteers. They have done wonderful work, uh, keeping track of everything, maintaining the social media, sending out irritating emails to all the attendees again and again. And finally, thank you for all the speakers. You are kind enough to accept this invitation, and AI Journal uh, for sponsoring the project and making this project a success. So yeah, adieu, but perhaps surely we are meeting next year. Thank you.
Thank you. Thank you, everybody.
Thank you.
Thank you.
It's an amazing session.
Thank you. Okay. Bye.
Thank you, Nilo, and everyone else.
Thank
Bye.
you.
Thank you.
Bye, everybody.